Hi again. Today we're going to cover Trig, Pre-Calc 12, Trig applications. The Ferris wheel, it's a typical question that you get on the test all the time. Um, it's very important that you don't memorize and try to think about what's happening with the wheel and how you transfer that into a wave graph right in here. Okay, so let's read the question together. A carnival Ferris wheel with a radius of 14 meters makes one complete revolution every 16 seconds. The bottom of the wheel is 1.5 meters above the ground. If a person is at the top of the wheel when a stopwatch is started, determine how high above the ground is the person that person will be after 1 minute and 7 seconds. So let's look at what's happening. So the Ferris wheel is 1.5 meters above ground. So show that on the graph here because this is the height right here, and this is the time. And when we start, the person, when time is 0, the person was right on top, as you see him there smiling. So the person was right on top. Now it takes 16 seconds to make a full revolution. So what's happening, this person will go around and come back to the top in 16 seconds. So basically after 16 seconds, he's going to be right on the top again. So these points are important. Now this is a uniform motion. You know, the wheel is making a uniform motion. So therefore, if it takes 16 seconds to go from the top and get back to the top again, so in 8 seconds, you're going to be right at the bottom, which is 1.5 meters above ground. So this is, you know, if you look at it, here are the points that are important that you have to show me on the graph right there. So what's happening in 4 seconds, he's going to get right to the center or the center line right here. So in 4 seconds, the person will be at a height of 15.5. Since the radius of the Ferris wheel is 14 and you're 1.5 meters above ground, so if you add the 1.5 and the 14, you'll get where the center of the Ferris wheel is relative to the ground. So it's 15.5. And then the top, you just add the 14 again, which is the radius, and that will take you to 29.5, and that's where the top is. So now, after 4 seconds, he's going to be right here if the Ferris wheel is going this direction. And then after 8 seconds, he's going to be right at the bottom. And then in 12 seconds, he's going to be right there. And that's where that is. And in 16 seconds, he's going to get back on top. And then what I did, I divided the 16 by 4 to show like where all these points are going to be. So it's going to be 4, 8, 12, 16. That's how you divide the period. Now, once we have this, we could plot the graph. Now, we have to translate this graph into an equation. So that's y equals, you know, the amplitude. The amplitude is basically measured from the center line to the top or the center line to the bottom. That's the amplitude, and that's obviously 14. It's also the radius in the Ferris wheel. So it's 14. And then, since we know the cosine graph starts at a max, so that's what the cosine does, it starts at a max, and this starting at a max is better to use a cosine function here. And then here's b, and b always, so let me just write underneath here, y equals a cos b x minus c plus d. D is the vertical displacement. C is the phase shift if the graph shifted to the right or left. B is to find the period, and B always equals 2 pi over the period. So here, if we want a calculator here, it's going to be 2 pi over 16 because the period is, the Ferris wheel makes a full period in 16 seconds. So 2 pi over 16, which reduces to pi over 8. And that's what's going to go in here. Now the maximum here is right on the y-axis or the height axis. So it didn't shift left or right. So we don't have a phase shift. So here the x is just going to be t because it's time. Plus the vertical displacement. The vertical displacement is always the center line, which is right here. And this is your center line. So it's plus 15.5 because that's where the center line is with the relative to the ground. And this is the equation now that you could use to solve anything for this Ferris wheel. Now, the second question after you write that is, here we should maybe call it h of t equals, which is the y, because its height equals this with relative to time, or with respect to time. So now they say, what's the height, or how high above the ground is the person 1 minute and 7 seconds after they start? So basically 1 minute and 7 seconds, that's here, that's just 67 seconds, because 1 minute is 60 seconds. So to find the height of the person in 67 seconds, or a minute and 7 seconds, you just plug in the 67 seconds for the time plus 15.5. Now to answer this, make sure you set up your calculator in radians mode, and then you just plug this in as is in your calculator. So you go to radians mode, then you go 14 cos, make sure you put brackets, and you go in brackets again, pi over 8 in brackets times 67, close the bracket again, and then plus 15.5, and you should get the answer. Make sure, because order of operations, the calculator doesn't understand what you're trying to do. It's this here, and those brackets here are very important that you show them this way in the calculator. So you go brackets, and then open another brackets, put a pi, and then divide by 8, close the bracket, and then times 67, close the bracket again, and then plus 15.5, and then your calculator would do that in this order. So let me do that in the calculator and get the answer. And the answer is 20.9 meters above ground. So 67 seconds, or 1 minute and 7 seconds later, is 20.9 meters above ground. Now, always, your answers have to make sense to you. So let's say you ended up getting 50 for the answer. You cannot get above 29 unless you're gonna really shoot that person off the Ferris wheel up another 21 or so meters above ground. But always your final answer should make sense to you. So again, make sure when you're doing this, you're in radians mode. And this is it for Ferris wheel. Some Ferris wheel questions, you'll start at the bottom here, so instead of starting on top, you'll start right here. So you should finish right here then. And then this will be all the same, except your 14, you'll throw a negative in front of it because you started at the bottom. That means the cosine graph, now it's flipped. And if it's flipped, that thing that does that is the negative sign right in front of the amplitude. So I hope this helps you. Don't forget, hit the like button and subscribe to my channel. Thank you for watching. Have a great weekend. Till next time. Bye-bye.